Welcome back to my YouTube channel. We're given question 2 reads as follows. Calculate the number of contact pairs required in a plate class to transmit 240 kilowatts at 1200 rests per minute. The diameter of the friction plates are 240 millimeter and 180 millimeter respectively. Assume that the coefficient of friction is 0,2. The normal pressure between the contact is 4. You have given 400 kilopascal where uniform. We know that is for RF. That means if it's where uniform, will be R over 2 that, right? So it's fine. This is what we have so far. So guys, as we have this now, we can do our stuff here. We say you should calculate the number of contact pairs, right, required. To calculate that, we want n. It's fine, we want n. That is beautiful, but you know that where can you get n? N is from this formula torque. It's where we found n multiplied by F Asial multiplied by RF multiplied by n. This is what we want there, isn't it? We want this. If I make n the subject, I will have t into, I will divide by all of that, then I will have multiplied by F applied multiplied by RF. So to find n, you're supposed to find the torque, find the applied force, and find RF, then we are done. So where can we get the torque? We know that is nicely power is equals to pi n t over 60. It's where we'll get the torque. If you make the torque the subject, will be 60 p over 2 pi n, right? So 60, what is the power? We're given the power there. It says 24 kilowatts. Then this will be 24 times 10 to the power of 3, right? Divide by 2 pi. Then what about the numbers of numbers there? The speed, there's 1200. Okay, the speed, fine. This is what we have. If you may, if I quickly, let me quickly punch that for, if I can punch this, what is the torque there? The torque will be, I want the torque will simply equals to 190,99 Newton meter, right? We have the torque. So we have the torque. Now we are done with this one. Let's find now let me see RF. For argument's sake, RF is equals to R plus R over 2, since it's a uniform what? It's a uniform wear. So what is our R? Outer radius is the big one here. Divide by 1000, you'll get 0,24. This is your R. Then small r, we divide by 1000. We're given these were diameters. Okay, those are diameters again. Is supposed to divide this by 2. Yeah, we'll divide that by 2, which will be 100 and will be 0,12. That means r will divide by 2 will be 0,12 meter. Then r there, if you divide that 0,18 by 2 will be 0,08. So it's fine. There we have our RF there. So we have here 0,12 12 plus that 0,09 over 2, then that what will be this? If we can say 0,112 plus 0,09, then you punch this, you divide this by 2, you get this to be 0,105 meter. We have RF there. So we are done with that. What is left now? It is force. If we can find the force, axial force. If you can get axial force, this is actually pressure multiplied by area, whereby the area is pi into r squared minus r squared. So the pressure hopefully we're given there, which is 4 times 10 power of 3. Yes, pressure 400 times 10 power of 3 multiplied by n. We know that our r there is 0,12 squared minus 0,09 squared. Then our axial force, suppose we get that axial force is zeroed. We want the axial let me say 4 times 10 to the power of 3, guys. Multiply that by pi, multiply this by 0,12 squared minus 0,09 squared. I got 7,916,813. This is measured in Newton, isn't it? It's a force. Since we have the force, now we have the force. We have this. We know the coefficient we've been given, so we can simply find n by substituting torque. We simply calculated there, which it was 90,99. Is it? Yeah, 90,99. 190,99 over coefficient of friction, which it was 0,2. Here it is. Coefficient of friction is 0,2 multiplied by I'm applying this formula now, multiplied by the force, the one that we've calculated here. It is 7,916,813 times RF there. Here it's our 0,105. 0,105. So what will be n? Let me punch this. 190,99 0,2 times 7,916,813 times 0,105. We get that this is 0, that is what we have there. Right. So this is approximately to 1. The same as 1 must be still here. Yeah, I can just say 1. It's approximately to 1. I had one number of contact. Right. Then that means this plate is not a normal plate. That means it's like this. If you had the number of contact, here will be the plate. Then we'll have the disc. So here will be the contact here. So where is another pair? We're supposed to have, and that means this pair, this side is broken. It's is not active. So this is a completely worn. It's a worn clutch. This thing cannot be like this. A clutch. This is not a complete clutch. It's very worn. Actually, this thing is doomed. You cannot, yeah. So as it is in mechanic, this is doomed, yeah. It's very bad. So it's very worn. Yeah, it's a way. That didn't make sense. So thank you guys for your time. Please do not forget to subscribe there, to subscribe to my YouTube channel. Subscribe there and click that notification button so that you'll be notified whenever I post a new video. See you in the next comment session. Stay tuned. You can share this to your fellow classmate. You can comment, you can like also them.